Greetings of the day, dear students. In this video, we are going to discuss about the FET construction and its a principle of operation, junction field effect transistor. We are going to discuss, and we will discuss what do you mean by N-channel junction field effect transistor and P-channel J-effect, and also what are the functions of source, drain, gate, and the channel. What do you mean by channel in a junction field effect transistor? And also we will discuss about its operation in three different modes, that is when VGS equal to 0 and VDS equal to 0, and when gate source voltage is made 0 and drain source voltage is increased from 0, and also when the gate source voltage is made negative and drain source is increased. So these are all the different cases we will discuss in this video, right? Yeah. Dear students, if you observe, just like our resistor, which is having some two terminals, if you recollect resistor, which is going to have the two terminals, and similarly a diode, which is going to have anode and cathode, two terminals, and previously we have discussed in our videos NPN transistor or PNP transistor, which is having some three terminals. Here also the FET or JFET, junction field effect transistor, is basically a three-terminal semiconductor device. It is a three-terminal semiconductor device, right, in which the current conduction will be by one type of the charge carriers. It will be the mode of conduction will be due to the charge carriers. Now what will be those three terminals? Those three terminals are named as gate, right, G, source and drain. Gate, source and drain are the three terminals we are going to have, right? Now it is going to consist of either a p-type or n-type silicon channel or a bar, right? It is going to have some two p-n junctions on both sides, and it is going to form the conducting channel for the charge carriers. Simply to say, it is of either a p-type or n-type silicon bar. I repeat again, it is of either p-type or n-type silicon bar and containing two p-n junction diodes on both the sides. Now if the silicon bar is of n-type, then it is called n-channel JFET. Very, very important. If the silicon bar itself is of n-type, it is called n-channel. If it is n-channel JFET, the source will be n-type and drain will be n-type. You can observe in this figure, and the gate will be p-type and the gate will be p-type, right? Now if the silicon bar is of p-type, it is called p-channel JFET. If it is a p-channel JFET, in this context the source will be p-type and the drain also will be p-type and the gate will be n-type. So up to here we are having two types. One is the n-channel JFET, depending upon the type of the silicon bar. If it is p-type silicon bar, it is a p-channel JFET. If it is a n-channel silicon bar, right, it is called n-channel JFET, right? Now how do you understand the source? That is the terminal through which the majority charge carriers will enter the channel. The terminal through which the majority charge carriers are entering the channel, that channel is to be called as source terminal. Now the terminal through which the majority charge carriers leaves the channel, it is to be called as drain terminal. Now the gate will be heavily doped. The p-type silicon will be diffused on both sides of the n-type silicon bar. If it is n-type silicon bar, then the gate will be p-type. If it is p-type silicon bar, the gate will be n-type, right? Now what about the channel? That is the region between the source and drain. and the sandwich between the two layers, it is a sandwich between the two gates, that is called the charge channel. Now through this channel, the majority charge carriers will move from source to drain through this channel. So here, simply to say, the source, the terminal through which the majority charge carriers enters the channel is called the source. Here this is the source. The channel through which the majority charge carriers leaves the terminal is called the drain. This is the drain, right? If it is N channel JFET, the source will be N type and the drain also will be N type and the gate will be P type. If it is P channel JFET, the source will be P type, the drain also will be P type, and the gate will be N type, and the gate will be N type. So these are to be highlighted while attempting the question on this topic. You have to highlight what do you mean by source, drain, gate, channel, and what is its equivalent circuit diagram symbol, right? If it is N channel, the arrow is like this. It is if it is P channel, you have to indicate arrow like this. You have to draw the symbol like this. You have to encircle. You have to indicate the drain current direction. If it is P channel, the drain current direction will be like this. If it is N channel, these are the points to be highlighted while drawing this diagram. You have to give the proper naming. Where is the source, drain, gate, and directions of the gate current and drain current depending upon the type of the channel. Then easily you will get the marks. Now what could be the operation? What could be the operation? Here the gate will be always reverse bias. If you recollect the diode, right? If you are having an anode and cathode, to make it forward bias, what we are doing? Anode is connected to the positive terminal, right? Cathode negative is connected to the negative terminal. So this is leading to the forward biased state. The same diode, if you recollect, if to make it reverse bias, anode and cathode we are having, anode is connected to the negative terminal and the cathode is connected to the positive terminal, like this, negative, positive, and here this is the anode and cathode, right? Anode is connected to the positive, cathode is connected to the negative, and this is under reverse bias. So these are the previous basics, right? Here also the gate is to be always reverse bias. Here it is gate. This is the gate, source, drain, gate, right? This is the N channel MOSFET. So obviously this is of N type, and this drain also will be of N type, and now this gate will be of P type. This gate will be of P type, right? Now as and when the gate is to be always reverse bias, so because of that, as the gate is reverse bias, right, the gate current will be practically 0. Now the source terminal will be connected to the end of the drain supply. The source and drain are to be connected. Right, which provides the necessary charge carriers depending upon its type. If it is a N channel JFET, source is always connected to the negative. When if it is N channel, and obviously the drain will be connected to the positive terminal. Right? That point is important. If it is P type, if it is a P channel JFET, the source will be connected to the positive end and the drain, positive end of the drain voltage. These two differences are important. Simply to say, if it is N channel JFET, source is connected to the negative terminal. If it is P channel JFET, source is connected to the positive terminal. The gate is obviously it is made reverse bias. Now what are the different possibilities we are having? For example, if gate source voltage is made 0, the gate and source, if this voltage is VGS is made 0, and also drain source voltage VDS is also made 0, then what happens? When no voltage is applied between the drain and source, and also between the gate and source, right, the drain current will be 0. Very, very important. Simply there won't be any current flowing through the drain. The drain current ID will be equal to 0. Here no current flows. If it is N channel, in N channel the drain current will be outwards like this. The current will be 0. Now other possibility is there. VGS is kept 0 only. This VGS is kept 0, but now the VDS is increased. As it is N channel, you can observe the source is connected to the negative and the drain is connected to the positive. Now this VDS value is slowly increased. Already the gate and source, this gate and source are reverse biased and also no voltage is applied, right? Now slowly you started increasing the value of VDS. What could happen? As it is forward biased, right? Now there will be some depletion region. There is already a depletion region. Now this VDS gradually increases from 0. ID also increases proportionally. The drain current also increases slowly. If you increase the value of VDS slowly from 0 to some other higher values, the drain current value also will increase. This is very, very important, right? The majority charge carriers in N channel MOSFET, if it is N channel, the majority charge carriers will be electrons, right? The majority carriers, that is electrons, will flow from source to drain through the channel between the depletion layers, right? Now as the VDS is gradually increased from 0, ID also increases proportionally, and we can observe the increase in the drain current. Now other possibility is there. VDS is made negative. VGS is made negative. So this is P type and you are connecting here negative, and this is N channel MOSFET. This is already N type and you are connecting it to the positive. Now it is reverse biased, but VDS is forward biased, right? Now when reverse bias voltage VGS is applied between the gate and source and the VD is increased, the width of the depletion layer will increase. This is important. What will happen? As and when VGS is reverse biased, the width of the depletion layer will increase. Obviously the conduction region will get decreased, right? Therefore the resistance will get increased. I repeat again, if VGS, the reverse bias voltage is increased, the width of the depletion layer will increase, right? And it is going to reduce the conducting channel width. As and when depletion layer width is increasing, conducting channel width will reduce. Because of that, it is the resistance is going to be increased. As the resistance is going to be increased, the flow of current will be reduced. So consequently, the drain current from source to drain will be decreased. Very, very important. The current from source to drain will decrease when if VGS is made negative. Similarly, if you are still making VGS more and more negative, you will reach a point where, right, no current will flow. That point is called the cutoff point, and the voltage where no current is flowing from source to drain, that voltage is to be called as pinch off voltage. Dear students, simply observe, you are slowly increasing the value of VGS. The VGS value you are slowly increasing, right? Slowly you are increasing the value of VGS at some particular value of VGS. Okay, there won't be any current flowing from source to the drain. That value of current is that value of voltage is to be called as pinch off voltage. Pinch off voltage, because the width of the depletion layer has increased more and more. The resistance has increased more and more. No current will flow further, right? So that voltage is to be called as pinch off voltage, right? On the other hand, if you are going to decrease this VGS voltage, this VGS is reverse bias, but now instead of increasing, now if you are decreasing, if the reverse voltage is on the gate is decreased, the width of the depletion layer also decreases, the resistance decreases, more amount of current will flow from source to drain. More amount of current will flow from source to drain. Like this, by controlling the gate VGS, by controlling the VGS voltage, either whether it is 0 or whether it is more negative value or less negative value, we can control the amount of current flowing from source to the drain. That is, the drain current can be controlled. That is the reason why this is also called the because all this happens because of the electric field change, the field effect transistor. This is also called as field effect transistor. So dear students, simply to say, by controlling the gate source voltage, you can control the width of the depletion layer. You can control the width of the depletion layer. If VGS is made more reverse bias, the width of the depletion layer will be more, the conduction layer will be less, the resistance will be more, current will be less. If VGS is made, if VGS is decreased, reverse voltage is decreased, the depletion layer will decrease, the conduction layer will increase, and the resistance will be less, the conduction will be more, right? So these are the different modes of operation depending upon the type of the channel. Dear students, if it is here, it is important. If it I will show you here. If it is N channel, the source and drain are to be N type. If it is P channel, the source and drain are to be P type, and the gate will be opposite to that. JFET is a 3-terminal device consisting of 3 terminals: source, drain, and gate. The source is defined as the terminal through which the majority charge carriers enters the channel. The drain is defined as the terminal through which the majority charge carriers leaves the channel, right? So that is the source and drain. Gate is a heavily doped p-type silicon, right? This is the equivalent circuit diagram. So this is what all about the FET, field effect transistor construction and principle of operation. Okay, thank you.